Myself Amrita. To this presentation on effect of diaphragm action on moment resisting frame under seismic load. First, introduction. Diaphragm, a horizontal system acting to transmit lateral forces to a vertical resisting element. Types of diaphragm: rigid diaphragm and semi-rigid diaphragm. First, rigid diaphragm. A diaphragm may be considered rigid when at its midpoint displacement under lateral load is less than twice the average displacement at its end. Semi-rigid diaphragm, that is a flexible diaphragm. A diaphragm may be considered flexible when the midpoint displacement under lateral load exceeds twice the average displacement of the end support. Next, this is a diagram isometric view of basic building structural element. Next, role and action of diaphragm. First, below grade soil pressure. Next, inclined column. Next, moment resisting frames, lateral load, lateral thrust. Okay. Next, problem statement. Here present research involves the study of effect of slab diaphragm action on moment resisting frame and effect of this model on different seismic response of building like story shear, story displacement and story dip. Objective of the study. The main objective is to study the structural behavior of different types of diaphragm under seismic load. Next, to compare the study of different result in different parameters like story shear, story displacement, peak story, drift. Okay. Next, research methodology. First, selection of building geometry, base and story, selection of diaphragm. Next, formation of load combination, modeling of building frame, analysis of considering different diaphragm models, seismic zone and load combination, and last, study the result in terms of story shear, story drift and story displacement. Next, modeling of moment resisting frame. The building models of G plus 5 story and G plus 9 story. The analysis is performed by using ETAP software. This is a parametric parameters of building. Next, this is a plan of G plus 5 story building. This is a 3D view of G plus 5 story building. This is a plan of 9 story building, G plus 9 story building. This is a 3D view of G plus 9 story building. Next, result and discussion. Story shear. It is the maximum lateral force that will occur due to the seismic ground motion at the base of at the story of the structure. This is a result of story shear for G plus 5 story RC building frame. For rigid diagram at story 1, 1344 kilonewton, and at story 6, 233 kilonewton. For semi-rigid diaphragm, 1881 kilonewton, at story 6, 327 kilonewton. For without diaphragm, at story 1, 2688 kilonewton, and story 6, 467 kilonewton. Same as it is for the G plus 9. So at story 1, that is a maximum story shear, and story 10 minimum story shear for rigid diaphragm, semi-rigid diaphragm and without diaphragm. It is concluded that maximum story shear occurs, maximum story shear story of the structure increases, the story shear will be decreases. Next, story drift. It is the displacement of one story with respect to the other story. This is the result of story. This is the result of story drift for G plus 5 story. For rigid diaphragm, for at story 1, it will be 0.0034, and at story 6, 0.01. At the middle, story 3, it is for 0.004. It's same as it is for the semi-rigid diaphragm and without diaphragm. For next, for G plus 9 story, it will be story drift will be story at 1 will be greater, at mid it will be increases, and then story 10 at will be decreases. Means that the maximum story drift usually occurs at mid height of the level, and in quotes decreasing from mid height towards the roof level. Okay. Next, story displacement. It is a displacement of a story with respect to the base of the structure. This is the story displacement result G plus 59 story. For rigid diaphragm, it will be 10.88 mm and at 6 story 59.4. For semi-rigid diaphragm, at story 1 15.1 mm and at 6 story 83.2 mm. Without diaphragm, it will be at story 1 21.6 mm and story 6 118.9 mm. Same as it is for at story at the base, it will be same will be at story 1 it will be lowest displacement, as this increasing the story of the building, this will be this displacement will be increases. It will be conclude that the semi-rigid diaphragm and without diaphragm produces more displacement as compared to the rigid diaphragm. This is a comparative result for RC building frame for rigid diaphragm, semi-rigid diaphragm and without diaphragm. This will be the maximum story shear, story displacement and story drift. Okay, this is for G plus 5 story building. Next, this is for the G plus 9 story RC building. This will be rigid diaphragm, semi-rigid diaphragm and without diaphragm. Maximum story shear, maximum story drift and maximum story displacement. And this is the graphical show. This is a rigid diaphragm, semi-rigid diaphragm and without diaphragm. This is a story shear, this for the story drift and this for the story displacement. Next, conclusion. It is concluded that as story of the shear increases, the story shear is decreasing. The maximum story shear occurs at base level due to direct ground contact of the structure. Next, the rigid floor model is accurate as semi-rigid model without diaphragm. It is concluded that building with rigid diaphragm is good assumption as compared to semi-rigid diaphragm and without diaphragm. Future scope. The current study involves the response spectrum analysis, and the same work can be extended for non-linear analysis, that is time history analysis. Next, these are the references. These are the standard course books. Okay, thank you.